Hey geometry students, Mr. Hill here to show you an example of finding the volume of an irregular object, and then I'll compare that to my other object. Hopefully, or probably, you are coming from this video where Vanessa found upper and lower bounds for her plastic cup, and my objects down here were a paint can, and this is an old school GameBoy carrying case that I still have from when I was single digit age. Now my paint can is just a cylinder, but this GameBoy carrying case, it's almost a rectangular prism, but it has this little extra carrying area at the top, and that's what I'm going to have to add on or estimate around. So the first thing I'm going to do is take some measurements and do a drawing. So I will be right back once I've done that. Alright, so there's my diagram. I've taken all the measurements of the case. You can see it's about 3 inches tall, 4.75 inches wide, 12 inches in the other direction, and then there's an extra 2 inches for that carrying handle. I don't know how well you can see it in the picture, but here's the handle. Hello, can you see that? You can see that, yeah. So here's the handle. It's got this little bit of extra volume that goes through here. So the biggest possible shape that could contain this would be a rectangular prism that goes over the whole thing, right, all the way up here. And the smallest possible would be a rectangular prism that does not include that handle. So you can see I've actually split this measurement, I already said it, into 12 inches here to here, and then 2 inches up top. Alright, let me put this down, and let's do a little bit of math. So, here's my hand. So, we get to choose what our base is for our rectangular prism, and I thought it would be pretty easy if we chose this as our base, because that will then apply to 12 inches as the height, and then also 12 plus 2 inches as the bigger height. So let's first figure out our base area, B. You'll notice we use a large B for area of the base. And for the area of a rectangle, we just multiply the two dimensions, width by length, or base times height, whatever you want to call it. It's a little confusing if you use base again, but it's a lowercase b. Here's what we've got. This is something I might be able to do in my head, but I know I can pull up my calculator and do it that way. You can't see that very well. Let me move that in here. There we go. There we go. That's better. So we've got 3 times 4.75, and that's going to give me a numerical answer of 14.25. And my units are inches times inches, which is inches squared, right? When we multiply something by itself, it becomes squared. I'm having a little trouble drawing some things, so I'm going to pause the video and I'll be right back. Alright, I think we solved whatever that was. So, you can see that the base for either of these is going to be 3 times 4.75 inches, and that'll be 14.25 inches squared, or square inches, which is literally a square that's an inch on each side. That's how we measure area in inches. Alright. So that base works for both our small and our large volumes. For our small volume, we're going to write volume, and I'll put a little sub s for small. That's going to be base times height. The base is 14.25 inches squared. And the height, remember, is just the 12 inches, because that's the height for a rectangular prism that is smaller than our GameBoy carrying case. So we'll multiply 14.25 by 12 in our calculator and get a nice round number. Wow. 100. 171. And now we've got inches squared times inches. So it's inches times inches times inches. That is inches cubed, or cubic inches, right? All right, so that's the smallest possible volume. For the largest possible volume, and again, where's my cursor? There we go. We will put a little subscript L for large. We'll use base times height. The base is the same, 14.25 inches squared. And the height this time, we're going all the way across. So I'm adding the 2 and the 12 to get 14 inches. And let's type this in. It's 14.25 times 14, which is, wow, almost 200. So I've got 199.5, and again, this is cubic inches, or inches cubed. All right, so that's me finding the largest possible volume, the smallest possible volume. I know the actual volume is somewhere in between, and now I need to use my judgment. Should it be closer to the upper bound, the lower bound? Based on this shape, this is mostly empty space, and the handle, in fact, is even triangular here, so it's not even filling the whole thing. This is going to be much closer to that smallest possible volume. Now, I could do some additional calculations, and if I was doing it, I would actually try to maybe figure out what is the volume of this handle right here, because it's almost a triangular, or a rectangular prism. This is almost a triangular prism. But for us right now, I'm just going to guess. But it's an educated guess, which makes it an estimate. So I know the smallest possible volume was 1.71. I am going to take a number that is closer to that than 200, so closer to 170 than 200, rounding. So I'm going to say volume, and I might put an E for estimate, but if I was turning this in, I would not. I would say just volume. I would be confident. So volume is equal to, and I'm going to say that it is 175 inches cubed. So a little bit more than our minimum, but not very much. Okay, and I would be able to explain that in writing, explaining my reasoning, which you will be or have been asked to do in your assignment. So that's an example of finding the volume of a complex object, or an irregular object. It's not made up of simple objects, but we can use simple objects to get an upper and lower bound, and then we know we have to guess between those. And we make an educated guess. In my case, I guessed a little above the minimum because most of the extra space that I calculated, the extra volume I calculated, was empty. I hope that's helpful to you. Reach out to your teacher if you have any questions. We are happy to help you. And it's Hill out.